Okay, so we said we're doing the geometric sequence. Now the not the geometric, quadratic. The quadratic sequence, the one thing about the quadratic sequence is that we don't look at the sum. We don't have a quadratic series that we look at. We only look at the sequence. Okay, it's a grade 11 topic. But same thing applies. We still have term 1, term 2, term 3. Okay, the difference this time is that how can I explain it? Well, let me explain it like this: that term 2 is term 1 plus a value, some sort of value. Term. Oh yes, I could. Sorry. Term 2 is term 1 plus a value. Term 3 is term 2 plus that same value plus another value. And now term 4 is term 3 plus the same value plus 2 of these values. Okay, so I want to show you that the difference between the terms forms a what?
The difference between
look, term, this is the difference. So for example, there's term 1, term 2 is now term 1 plus a. So the difference here is term 3 is term 2 plus a plus d. So the difference between these two is a plus d. Term 3 is, or term 4 is term 3 plus a plus 2d's. So the difference between this one is a plus 3d. So this will form what we call a quadratic sequence. 2d, sorry. This is called quadratic. Okay, but now look at the difference, the first difference. What do you recognize here? Do you recognize anything? Come on. Huh? No, doesn't it look familiar?
It does. It looks like the arithmetic.
It is the arithmetic thing. The first difference for a quadratic sequence is an arithmetic sequence. And then if we find the constant difference here, we can see that this time there's a constant difference between these two. So the second difference has a constant difference, okay? But yes, if we look at the pattern produced by the first difference, it will create an arithmetic sequence. Okay, so with that in mind, let's quickly go and look at if we had a constant difference. How am I going to? So okay, so we call it quadratic because in the end the general term would be given by the quadratic equation, an squared, or the quadratic form, bn plus c. Okay, now just like the other two, this one, if I were to plot it on a graph, will look like a parabola. The only difference is we are only using, so if a parabola looked like this, we will only be using that point, that point, that point, that point, that point. Do you understand what I'm saying? So it will be little dots that form a parabolic shape. Okay, so that's the one thing. It will also have a turning point, a minimum value or a maximum value, depending on whether this A is positive or negative. If it's positive, it will have a minimum value. And how would we find the minimum value? Okay, negative B over 2A. That would give me an N answer. The N for which I will have the smallest Tn. Okay, so there's the same relationships that apply to graphs still apply here. If there's some sort of relationship in the in them. Okay, but I don't want to go too far down that road. What I do want to show you is that T1 is then equal to, okay, T1 is A plus B plus C. Term 2 is when I put a 2 in here, that gives me 4, because this is 2 squared, that's a 4A plus 2B plus C. T3 would be 9A plus 3B plus C. And term 4 would be 16A plus 4B plus C. And now this is literally my terms, how I would find them. So now let's take the constant difference between them. Okay, and here we see if I take this and I subtract that, look what I get. I get 3A plus B. Here and here, what do I get? 5A plus B. Between here and here, what do I get? 7A plus B. Can you notice the arithmetic sequence? Okay, what's my first term? 3A plus B. What's my constant difference? 2A. So, what's my constant difference? 2A. 2A. So notice here we have our formulas to find. So 2A is equal to my second difference. 3A plus B is equal to my first difference, but my first difference isn't constant. It's my first difference. Okay, do you get what I'm saying? My first difference. There's a second first difference as well. Okay, and a third first difference. Okay, and then A plus B plus C is equal to my term 1. But I have a different formula that I use. I love this one. Okay, I go back one extra step. So what should, if there was another term, if there was a term 0, okay, what would it have been? Well, let's fill in term 0. If n is 0, what would I get? 0. No, n is 0.
N is 0, 0 squared is 0.
Is 0 squared, and then? Plus 0 plus C. So T0 would be C. Okay, that would be nice. Okay, if this one is 3A plus B, that one is 5A plus B, what would the previous one be? A plus B. What would this one be? 2A. So in other words, if you go backwards, just one step backwards, then you have that C is equal to T0. Okay. In other words, whatever you got by going one backwards. So let me give you an example. So let's say we have a number pattern. Let's go for 13, 15, 20, 19, 19, and one more, so 4, 6, 25. Okay, now let's get the constant differences. This is constant difference here is 2, 4, 6. Okay, my common difference here is 2, 2. Now what I'm saying is let's go back one more. So this one must be 2. This one is 2, 4, 6. What do you think was this one? 0. So what do you think term, this is T1. What do you think T0 was? Look, 13 plus 2 gives me 15, or 15 minus 2 gives me 13. 13 minus 0 gives me 13. And this is what I'm saying. If I now use this, I've got a much easier set of equations. C is equal to 13. A plus B is equal to 0. 2A is equal to 2. So A is equal to what? No man, C is equal to 13. A is equal to?
Minus B.
Yes, okay, A is equal to minus B, but there's an easy way. If 2A is 2, then A is equal to 1. If A plus B is 0, then B is equal to negative 1. C is equal to 30. You see how easy this one is? Tn is equal to n squared minus n plus 13. Okay, so let me do another one. You'll see it's easy. Let's go for minus 3.
But you're trying to exceed all the mistakes.
Okay, 5. Let's go for minus 1. Let's go for minus 3. Let's go for, so it's 4, 2, minus 3. Okay. So first we'll do is find our first difference. Get this one is negative 1 minus 5 is negative 6. Oh, sorry, wait, I made a mistake. Just let me fix it. Okay, so this one should be negative, it's negative 6, negative 4, negative 2, which is negative 3. There we go. So this, the difference is negative 3, negative 5 is, so no, but yeah, negative 3, it's negative 3, negative 5 is positive 2, negative 5, negative is negative, no, something still seems wrong. Okay, wait, let me see. Negative 1 is 5 minus 6, yeah, negative 6, negative 5 minus 1 is 4 is negative 4. So I'm subtracting 6 here, I'm subtracting 4 here, I'm subtracting 2 here, negative 3 minus. Okay, so there we go. So this is minus 5 minus, that's negative 4, and then negative 7 minus, that's negative 2. There we go. And here I go again, and I get my constant difference. Minus 2 minus, that's constant 4. 2 minus 4 minus 6, that's positive 2. Okay, so now again, notice that my constant difference here at the bottom must still be 2. So I'm kind of working one step backwards. What would be the difference one back, the first difference one back? Minus 8, it's easy to see that pattern. Now, 5 minus 6 gives me negative 1. Or negative 1 plus 6 gives me 5. Do you see? So 5? No? Look, minus 1 plus 6 gives me 5. So I'm changing the negative into a positive. Because remember, when we go backwards, I'm not adding my first difference, I'm subtracting my first difference. So it's 5 minus minus 8. So this is 5 minus 6 is 1. This is 1 minus minus 6. Do you understand what I'm saying? So when I go backwards, I must subtract this. And so 5 minus minus 8 is plus 8, which is 13. And then you can use that easy formula. C is equal to 13. A plus B is equal to negative 8. And 2A is equal to 2. So A is equal to 1. B is equal to minus 9. C is equal to 13. So Tn is equal to n squared minus 9n. Yeah, I have to.
It's very short. Yeah.
It's sure.
It's very short. This is lazy to write this thing, so we are lazy to think. It does everything.
Okay, so what else did we have to learn here? Okay, obviously finding the term. Okay, so now there are complex questions like the one we find here. I think there's only one quadratic. We've done that one, we've done that one, we've done that one. It's this one. Consider the quadratic sequence. Before we do that, let's just quickly see like the quadratic. The arithmetic property was that T2 minus T1 is equal to T3 minus T2. And we got it by noticing, but that's just a constant difference. This time we have a constant second difference. So let's see, in terms of T's, what do we get to? Term 1, term 2, term 3, term 4. We need 4 terms. Yeah, sorry. So I've got term 1, term 2, term 3, and term 4. Okay, now let's actually use this one. Now if I find the constant, the difference, the first difference is term 2 minus term 1. This one is term 3 minus term 2, and this one is term 4 minus term 3. Now these aren't equal, and that's what people kept doing in that equation. They kept taking here in this one, term 2 minus this one is term this minus that one, kind of, but that's not what it says. Okay, we must still take another one difference between that. So we can't use this property. That's not true. First difference is not equal. We must go another one down. So now we're saying that this minus that. So I've got term 3 minus term 2 minus term 2. So this must get a minus in front to get that. So it becomes term 3 minus 2 term 2's and then plus term 1, because the minus minus makes that a term 1, is equal to, and now these two, term 4 so this is, you don't have to go and remember this, of course, okay, but in our question we're trying to find term 1, 2, 3. So let's just solve term 3. So term 3 now will be, if we add term 3 on both sides, we will have 3 term 3's are equal to, and now everything else goes to the right. Term 1, there's a negative term 1, because term 1 is with term 3 on this side. So it goes to the other side, negative term 1. Term 2 is 2 negatives on this side, so when they go, they join the other one on that side, so we'll have 3 term 2's, and then just plus 1 term 4.
So,
Yes?
these two. Oh, okay.
Is that okay? And so term 3 is just equal to negative term 1 plus 3 terms 2 plus term 4 divided by 3. Okay, so let's say, so that's negative term 1 plus term 4 plus 3 terms 2. Okay, so it's negative term 1, so it's already negative 19, so it would be positive 19, plus term 4, which is 181 with a negative, okay, plus 3 times term 2, which is 55 with a negative, divided, that doesn't look right. That doesn't look good at all. Let's go back to my formula. Whoa, what's going on here? So term 4, it looks fairly good, but I think I'm messing up my signs. Let's try again. So it's negative term 1, which is 19, plus term 4. No, it's negative 19, but it's negative term 1. So it's negative 19, it's positive 19. Plus term 4, which is 181 with a negative. Okay. Plus, was it positive? That's positive term 2. Term 3, it does look right. But I think that's where the mess up comes. Okay, so plus 3 times 55 with a negative. Yeah, see now it's messing up this thing. Okay, so let me start with that. 3 times 55 with a negative. Okay, negative 165. It's just this stupid calculator. Plus, okay, plus my 181 with a negative, okay, plus my 19, okay, divided by 3. It's negative 109. Okay, is that also what you got? Cool. So term 3 is negative 109. Let's see. If x is negative 109. Okay, so, but, okay, so let me just, okay, so at least that gives you a target, but you're obviously not allowed to start from there. Can't use question 2 to say, okay, but you know what the answer should be. But let's quickly see, how could I have done it without using this formula? So we have negative 19, okay, negative 55, x, what was I last? Negative 188, 181. Okay, in this one, we can take our first difference, which is negative 55 from 19 to 55, I'm subtracting 20, 34, is it? 36. Yeah. Then the difference between these two terms is negative 55, or x minus is plus 55. And the difference between these two terms is negative 181 minus x. Are these equal? No, I must go down one more. And so if I go down one more, I get x plus 55 plus 36, plus, because it's minus 36, and on this side I get negative x, negative 181, negative x, negative 55. Are these equal? That's my second difference. And now I've got an equation that I have to solve x in. And you'll actually see it comes to exactly the same thing, because here is negative x, negative 2x. So when it comes to this side, it's negative, it's positive 3x, because there's now 3 positive x's, is equal to, and on this side I've got my negative 181, negative 55 is negative 236, 236, minus this one is 80, 91, negative 91 over, and then x is equal to negative 327, 327 over 3.
I like that one.
Yeah, so I mean, it's really exactly the same as this one. The only difference is here you're just using the values, while here you're just using the t's. You'll see actually it comes down to the same thing. So obviously, you can use any one of the two. To get this formula, you do exactly this. Okay.
Yes, I understand.
So do you understand? So once you know quadratic equation, you know you're going to have to use the second difference equal to each other.
Second. First. Second. That's fine.
Okay.
Okay.